Lesson 9. Gradient, Magnetic Flux. Section 9.5. Magnetic Flux. The magnetic flux can be defined based on the magnetic polarization. Assume that there is a magnetic field with a strength H0. A magnetic material is placed in the magnetic field, and if the material is isotropic, the tiny magnets align in the direction of the magnetic field. The facing N-S poles cancel each other out. Only the N and S poles on the surfaces of the magnet remain uncancelled. The surface charges generate a magnetic field with a strength of H'. The resulting magnetic field strength inside the magnetic material is denoted by H, and is given by H0 minus H'. The magnetic polarization Jm is defined as the density of induced magnetic dipole moments, directed from S to N. The magnetic flux density B inside the magnetic material is defined as the sum of μ0H and Jm. The unit is Tesla or Weber per square meter. The magnetic polarization Jm is proportional to the magnetic field strength H, and can be expressed by this equation. The coefficient Chi-m is a measure of how much a material is magnetized. Chi-m is called the magnetic susceptibility. Then B is expressed with this equation, where μr is the relative permeability. Suppose an open surface S, and the magnetic flux density B flows through S. Then the magnetic flux phi is defined as the area integral of B over a surface S, expressed by this equation, where ds is the differential area vector. If the surface is closed, like CS in this figure, then the N and S poles are always enclosed in pairs. Thus, the magnetic flux out of a closed surface is zero. This result holds for the magnetic flux out of any closed surface. The infinitesimal amount of magnetic flux per dV is, by definition, the divergence of B, and it is zero. This expresses the non-existence of magnetic monopoles. Exercise 9.5.1. Pause the video, and answer the problem. Show that the divergence of B is zero. The answer to exercise 9.5.1. Pause the video, and check the answer. Exercise 9.5.2. This is your homework. Pause the video, and answer the problem. This is a brief summary. In this lesson, we learned about the expression of the non-existence of magnetic monopoles. The author of this material is Takeshi FURUHASHI, Professor Emeritus, Nagoya University. If you have any questions, send emails to this address.